How to optimize MOSFETs in DC-DC power converters. Are you curious about how to make the most of metal oxide semiconductor field effect transistors in direct current to direct current power converters? Let's break it down step by step. Optimizing these components is all about balancing conduction losses and switching losses to achieve high efficiency. First, it is essential to understand the loss mechanisms involved. Conduction losses happen when the MOSFET is on and are proportional to the on resistance and the square of the current. Lowering the on resistance helps reduce these losses, but it may increase the size of the device and the gate charge. Next, switching losses occur during the transitions between on and off states. These losses are influenced by gate charge, switching frequency, and voltage and current conditions. Minimizing gate charge and optimizing the gate drive can significantly reduce these losses. One effective method for selecting the right MOSFET is the J/K method. This technique compares the ratio of conduction loss parameters to switching loss parameters. For synchronous buck converters that use both high-side and low-side MOSFETs, sum the J and K values of both devices to calculate the ratio. This helps narrow down the best options for your specific needs. Switching frequency and gate drive are also critical factors. Higher switching frequencies can lead to increased switching losses. Therefore, it is wise to choose MOSFETs with lower gate charge and input capacitance. Additionally, using optimized gate drive techniques, like low-voltage swing gate drives, can help reduce transition times and gate losses. Thermal management is another key aspect. Selecting MOSFETs with packages that have good thermal conductivity and low thermal resistance can help keep the junction temperature within safe limits. This not only improves reliability but also enhances performance. Using simulation and modeling tools can also be beneficial. Circuit simulation software and device models can help predict how the MOSFET will behave under dynamic conditions. This allows for evaluating efficiency, thermal performance, and stability before you even implement the hardware. When applying these concepts in real-world scenarios, there are a few practical considerations to keep in mind. For converters that handle wide input, voltage ranges, or high voltages, ensure that the MOSFET voltage rating exceeds the maximum input voltage with a margin. In multi-phase or multi-channel converters, matching the characteristics of MOSFETs across phases helps balance current sharing and efficiency. Lastly, implementing control strategies like peak current mode control can improve dynamic response and stability. This indirectly supports MOSFET performance by reducing stress and oscillations. In summary, optimizing MOSFETs in direct current to direct current converters involves a careful balance of conduction and switching losses. By applying systematic selection methods, optimizing gate drive design, and managing thermal conditions, you can achieve improved efficiency and reliability in your power converters.